Hey everyone, welcome to The Explainer. Today, we're diving into a tool that is honestly going to completely revolutionize how you handle mass spectrometry data. If you're a biologist or a bioinformatician working with proteomics, you already know the PRIDE database is an absolute goldmine. But getting that data on your machine, yeah, that can be a massive hurdle. Enter pridepy. It's a really powerful client designed specifically to access PRIDE archive data programmatically. So let's jump right in and turn you into a proteomics data automation expert.
Here is our quick roadmap for today. First, we'll look at the Proteomics Data Challenge. Next up, installing the pridepy package. Then, downloading data and raw files, understanding file transfer protocols, accessing datasets and metadata, and finally, citing the pridepy tool.
Section 1. The Proteomics Data Challenge.
Be honest with me here. How much time have you wasted just clicking through web interfaces? Imagine the sheer pain of trying to download terabytes of unwieldy proteomics data, literally file by file. Now, when the PRIDE database started as a production service way back in 2005, datasets were a lot smaller. But today, with high-res mass spec, we're dealing with massive, complex datasets covering dozens of species. We have all felt that heartbreak when a browser just freezes at 99% on a multi-gigabyte download. Manual downloads aren't just tedious anymore. They're a huge bottleneck from modern biology. And look, relying on web GUI downloads is notoriously slow and, frankly, super hard to reproduce. That's exactly why shifting to a command line interface, or CLI, like pridepy, is the ultimate solution. It is lightning fast, highly automatable, and absolutely perfect for high-performance computing, or HPC, and cloud environments. In a world where automated bioinformatics pipelines are basically essential, a CLI tool makes sure your data retrieval is scalable and perfectly reproducible.
All right, moving to Section 2, installing the pridepy package.
The devs over at MBEL EBI made getting set up incredibly straightforward. Step 1, just make sure your environment is running Python 3.9 or higher. Step 2, install it using your favorite package manager. You can totally use standard pip, but the documentation actually highly recommends using UV for a super fast, clean install. Oh, and there's a Conda recipe available too if you prefer keeping things inside your Conda environments.
If you're going with UV, it's so simple. You just type UV tool install pridepy right into your terminal. And that is it. One single line of code and you've got global access to the pridepy CLI on your machine. You can quickly verify it's working by typing pridepy --help to check out all the available commands.
Section 3. Downloading data and raw files.
Now, PRIDE is a founding member of the ProteomeXchange consortium, which coordinates data submission across a bunch of global repositories. And this is exactly what makes pridepy such a powerhouse. It's not just for PRIDE. It seamlessly navigates these interconnected repositories for you. You can pull datasets directly from Massive, JPost, iProx, and even PDC or CPTAC. For example, if you're pulling from Massive, it automatically routes through FTPS, but it has a built-in HTTPS fallback for networks that block FTP. It handles all that complex routing for you completely behind the scenes.
Let's look at a practical example. Say you want to download an entire dataset. You simply type pridepy, download all public raw files, throw in the -A flag for your accession number, like PXD008644, and hit Enter. This one command goes out, finds every single public raw file linked to that dataset, and pulls them down to your local machine or server. You can literally fire off this command, go grab a coffee, and pridepy does all the heavy lifting while you're gone.
Or, here's an alternative command scenario. If you want to specifically resolve and download raw files using a ProteomeXchange accession number, you'd use download px raw files. You can even tack on flags like -O to tell it exactly which output directory to use, or --checksum check to guarantee your files downloaded perfectly with zero corruption. It really gives you complete programmatic control over the whole process.
Section 4, understanding file transfer protocols.
So pridepy supports a few different protocols for actually moving these files across the web. By default, it starts with FTP and then falls back to others if it needs to, but you can tell it exactly which one to use. FTP is widely supported and super easy. Then there's Aspera, which is purpose-built for high-speed file transfers, especially over really long distances. And Globus gives you highly reliable transfers for absolutely huge datasets over an HTTPS endpoint. So which one should you actually pick for your own pipeline?
Well, the authors of pridepy ran a global benchmark test for their 2025 paper in the Journal of Open Source Software. And here's what they found. For smaller files around 14 megabytes, all three protocols perform pretty much identically. But when you scale up to large files, we're talking around 7 gigabytes, FTP gets highly variable depending on where you are. Sometimes it's fast, but its standard deviation is really high, meaning it can be wildly inconsistent. Aspra, though, it emerged as the most stable protocol by far, locking in around 10 megabytes per second with the lowest standard deviation. So if you're building a pipeline for massive raw files, just append --Aspra to your command. It's going to give you the most reliable results, hands down.
Okay, Section 5, accessing datasets and metadata.
Getting the raw files is only half the battle. Pride also interfaces directly with the Pride REST API to make handling metadata totally effortless. You can stream full project metadata straight into a JSON format. You can stream individual file metadata. You can even search through projects using specific keywords and filters all directly from the command line. Streaming this metadata programmatically is an absolutely vital step if you want to build really robust, reproducible downstream data analysis pipelines.
By running a command like pridepy stream-projects-metadata, you can pull high-level project data directly into your scripts. Think about it. Instead of manually scraping web pages just to figure out what species or mass spec instrument was used in a specific study, you instantly get structured JSON data that your Python or R scripts can read right away. It completely bridges that gap between raw data storage and actionable biological insights.
Finally, Section 6, citing the pridepy tool. Look, pridepy isn't just some random script someone threw together. It's a rigorously developed, peer-reviewed software package. It was published in the Journal of Open Source Software, or JOSS, in March 2025 by Selvakumar Kamachinathan and an amazing team over at the European Bioinformatics Institute. When we use open source tools that save us literally weeks of manual labor and enable cloud-scale biology, citing them is how we make sure the developers get the recognition and the funding they need to keep them running.
So if pridepy helps you download the raw files or metadata for your next big paper, please make sure this citation, Kamachinathan et al., 2025 in the Journal of Open Source Software, makes it into your bibliography. It is a super small step for you, but it's a massive help to the developers who built this tool.
And there you have it. You now know exactly how to install pridepy, navigate across all those ProteomeXchange repositories, pick the best transfer protocol, and stream metadata directly into your automated pipelines. You've officially got the command line superpowers to handle massive proteomics datasets without breaking a sweat. The only question left is, now that you aren't wasting weeks clicking download, what biological breakthrough are you going to discover next? Thanks for hanging out for this explainer, and happy coding!